So to remove this, take my 8mm and remove the two 8mm bolts. Notice that this bolt held down this wire. Okay, so we'll want to make note of that and make sure that this gets put back when we go to put it back together. Take the other one out. And now my Magneto comes off my engine. I'm done with this. I can set this in my locker in the back, out of harm's way. For the bolts, they're not really in the way here, so I'm going to go ahead and park them back in the hole. It's easier for me. Okay. Once I got that done, we're on step 20. It's now time to remove the flywheel and the flywheel nut and the starter cup and the flywheel fins. And to do that, we are going to need a 1/2-inch drive, 17mm deep socket. These are on there pretty tight, so we need a fair amount of torque, which is why we need the longer 1/2-inch drive handle. And because the flywheel is going to want to rotate on us, we need to use a flywheel holder to hold it in place while we try to loosen it. So what I'm going to do is this little tang right here is going to engage in one of the gaps on either side of the flywheel. It's going to fit into the gap on the side of the magnet, and since I'm going to want to rotate the nut counterclockwise, I need to hold the flywheel and prevent it from rotating in a counterclockwise direction as well. So I've got this set up, I've hooked it in. I'm going to take my ratchet, also set in a counterclockwise, and I got the handles relatively lined up to each other. Let me see if I can reposition you guys for this. So what I've got is I've got one handle right here, and I've got this one right here. They're close together so that I can take the two handles and I can pull them apart like that. What I want to avoid doing is having to cross my arms, okay? And so once I overcome the torque and I break it free, I should be done with this. Set that off to the side. Usually once it's loose, it spins free by hand, so I can set my ratchet off to the side. And then my nut starter cup will come off along with my flywheel fins. Okay, I'm going to set those off to the side. I'll reposition you down here to see more of the table. Alright, so once we got the flywheel fins and the starter cup and the nut off, we need a flywheel puller and a 5/8 wrench, because if I lift up on the flywheel, it doesn't just come off the engine. Okay, so I've got a flywheel holder, or puller, sorry, there's a flywheel puller from cabinet 11. And what I need to do is I need to back up the pressure screw and adjust the arms so that the arms will go underneath. The arms will go underneath and grip the bottom underside of the gear on the flywheel, and the pressure screw will push down in the center of the crankshaft. So back this up a bunch. I got to get that so that fits right there. I want to kind of make sure it's centered. I'll turn it by hand to take up the slack. Okay. So it looks something like this. Okay. They're hooked underneath as far as they can go. And I've got the center of the pressure screw in the center of the crankshaft. And then I'm going to take my 5/8 wrench. I like to use a wrench. Usually that's more than enough torque. I've got to use one hand to hold the flywheel puller from rotating, and I got to use the other hand to tighten the wrench in a clockwise direction. I'm just going to turn this until, well, it pops like that. Okay, so what that did is break the taper lock that's on there. So now I can set this off to the side, and now my flywheel lifts off. Okay, it gets stuck on there because this portion of the crankshaft right here has taper to it, and so does the hole in the flywheel. And so when you torque that nut down, these two tapers are very slightly mismatched angle, and so they actually jam together. Okay, and we want that. Okay. The key in here is just to hold the orientation of the flywheel magnet in the proper orientation to the crankshaft while it's being assembled. Okay. Speaking of the key, the next thing that we need to do is we need to remove that flywheel key. Because in order to take the crankshaft out later, that flywheel key's got to be out of there, or otherwise it won't pull through the seal in the bearing in the crankcase housing here. So set your flywheel off to the side. The nut, I usually tape down to your cardboard. And we'll do the same thing to the flywheel key. To remove this flywheel key, sometimes you can get lucky and grab them with a pair of pliers and pull them straight out. Most of these Toro engines, however, they're pretty tight, so we have to drive them out with a punch and a hammer. Before we get to that, also, this heat shield right here, this can go up on the gasket board next to your carburetor gasket. We won't be needing this again until we reassemble it. This heat shield is bolted to the cylinder block right here, and it lifts off of here. This can stay. This usually doesn't get in our way, so we can leave that there. Alright, so to remove the flywheel key, I'll leave the engine laying on its back like this on top of the engine stand, and I'm going to want to use a pin punch and a ball peen hammer. And what I'm going to do is I'm going to put this pin punch right on the end of the key that sticks up and out of the crankshaft here. I'm going to hold this right here. I'm going to try to avoid hitting the crankshaft at all, especially the threads. And I'm going to take my ball peen hammer. Oops, that one came off real easy. And just give it a little tap. If I get lucky, it's going to push itself right out because the bottom side of the key, this is called a woodruff shaped key, is a half round. And so if I push on it, the half rounded shape of the key seat in the shaft will push it out. Sometimes you got to tap it all the way out. Sometimes one or two hits and it's out. And then make sure you tape this down to your cardboard so you don't lose that little piece, because that's easy to do. And it's really hard to time your engine without it. So now that that's removed, it's time to go ahead and remove our starter motor. This is our electric start. A lot of snowblowers get 120 electric starters because battery starter systems aren't very reliable in the deep cold of long winters. And it's held on by two 8mm headed bolts. Okay, it might be a little bit snug, but they do spin out once you break them free. Spin these out, pull them up. When you lift up your starter motor, you may or may not have little dowels either left in the holes in the block, or they might be stuck in your starter motor. And they're fairly loose, they pull right out too. Okay, if they're in your starter motor, we want to take them out of the starter motor, put them in your block, and then take your bolts, park them back into the holes. These won't be in the way, and they will help hold your dowels into the holes so that they don't get lost. Having those dowels helps to properly align the starter motor, as well as make it easier to set the starter motor down and then put the bolts in and not have to worry about the starter motor falling out of place. Okay, so that's the starter motor. After that, it's time to set the engine up. I like to set it down at an angle into the square hole. It fits fantastically. So that way we can get a look at the valve cover here, because this is coming off next. Okay. Next thing we need to do, but measure the overhead valve lash or clearance. In order to do that, we're going to take the head off. We need to take the valve cover off in order to get to other bolts underneath it for further removal anyways. Okay, you'll see that it's held on by four 6mm bolts with 8mm bolt heads, and one of them has a bracket on it. It's going to be important to remember where that bracket goes because it needs to get back into that same location when you reassemble the engine. So I'm going to go ahead and spin these out. This is one where I do like to stick these ones in the cardboard and then also label this one as the upper corner that's right by the carburetor inlet port. I'll go ahead and label those later. We got it off for now. Sometimes they're a little stuck on here and you might need to give them a bop with your palm to get them loose, but then it comes off, okay? And then you should have a gasket underneath your valve cover. If it's stuck to the flange on the cylinder head, that's fine, leave it. If it's stuck inside your cover, that's fine, leave it. Just like the other gaskets, we're gonna see if we can get away with reusing them. I think mine actually looks like, yeah, it's shifted and moved, so it's a little bit loose. I'm gonna wipe up some of the excess oil, and then this will come off. I'll wipe up the excess oil on the other side, and then I'm gonna go hang it on the gasket board with all the other gaskets and keep it safe. Okay, step 23, checking the overhead valve lash or valve clearance. That is referring to the amount of space between the tip of the rocker arm and the tip of the valve. We need to have some allowance for thermal expansion to happen as the engine runs and warms up and the valves get longer. If we don't have some clearance there, the valve will actually start to hang open, and that will result in a loss of compression. So in order to get the whole process started, first thing I need to do is rotate the crankshaft till my engine is top dead center of the compression stroke. Well, Mr. Rakowski, how do we know when we're at top dead center? And how do we know when we're on the compression stroke? I'm going to tell you, there's some telltale signs. On this particular engine, the key seats in the crankshaft, when they are facing parallel with the cylinder, that means that the piston should be at or very near top dead center. And then if I'm on the compression stroke, both my rocker arms here, these are my rocker arms, these are the adjusters. Both of my rocker arms should have a little bit of movement. Not a lot, tiny little bit of play. The exhaust, which is this side here, should have slightly more than the intake, which is this side over here. Okay? What we're going to do is we're going to take a pair of steel feeler gauges like these ones. Fan these out so you can see them. We're going to be going after some of the thinner ones here. Okay? Like specifically a 6 and an 8 thousandths of an inch, and checking the clearance to see what it is. I'll start with the 5. This is my exhaust. Okay? Let me just show you something before I get to that point though. If I continue to rotate the engine over, you can see the valves open and close. But my key seats are facing up again. So my piston went down and back up, and now it's at top dead center again. But this is not the compression stroke. If I check, my valves no longer, my rocker arms no longer wiggle and clack against my valves. Okay, everything's tight. That's not the right place to try to measure. So I'm going to rotate the engine over full revolution again. My key seats are pointing up. If I look down the spark plug hole, I should have a pretty good view of the top of the piston. I can look and see the piston. And now my rocker arms have a little bit of play again. This tells me I'm at top dead center of the compression stroke. I'm going to take a feeler gauge blade and I'm going to come right in here, in between the rocker arm and the tip of the valve. And I'm going to stare and see if there's any drag. This is too loose. There's like zero drag on here. And if I try to move the rocker arm, I can still detect a little bit of movement by trying to move it up and down on top of the stem. So I'm going to try another thicker one. We'll try the 8 because that's actually what it should be set to. So put my 8 in here. A little bit more resistance. Okay. Still got a smidge of play in there, so I'm going to try a 9. 9 thousandths, 0.009. A little bit more resistance, but now I'm virtually no play. So I'm going to go ahead in my packet. I'm going to label my exhaust. I'm going to write down 0.009 inches for my exhaust valve lash. And then I'm going to repeat this process for the intake. Start with 5. It's pretty loose. Got a tiny amount of play in the rocker arm yet, so I'll try the 6. A little bit more resistance. Now I no longer get any vertical movement out of that rocker arm. So in my packet then, I'm gonna, for the intake valve lash, I'm gonna write 0.006 inches. Okay, and then you're at a checkpoint, number 26. You're gonna come find me and say, hey, Mr. Rao, I need a checkpoint. I just finished measuring my valve lash. Be prepared and have these ready, because I'm probably going to want to check your work and see how you did, and use this as an opportunity to offer you feedback on using feeler gauges, and in case maybe you didn't get it quite as accurately as you could have. Some people, they kind of pick this up right away. Other people, they need to practice using these and get some feedback on them and how they're using them in order to quite build and become competent in that skill. Okay, it's not a bad thing, but everybody's got their different dexterity levels.